My name is Aniket Ingoy and I am a PhD student at Florida State University. I work at HPMI and I specifically work in additive manufacturing lab. So according to ASTM standards, additive manufacturing is a process of joining materials to make an object layer by layer, usually as opposed to the subtractive manufacturing technologies. So it helps in reducing the waste of the material, because in regular subtracting manufacturing you have a block of material which is subtracted or removed, the material is removed, but with additive manufacturing you add specific amount of material to get the actual part. So at HPMI we have 4 different types of printers. The first one is called Object 30, which is from Stratasys, and it works on the principle of material jet modeling. It works on the same principle as the inkjet printer which we have, where instead of spraying ink, it's spraying polymer drop by drop to make a model. This polymer is cured with the UV light, and as one layer is deposited, it's cured with the UV light, the platform goes down and the next layer is printed on top of it. This process is repeated till the actual part is manufactured. The printer which we have, we can print different types of materials, from rigid to flexible type of materials. It also has a support material which is used when you want to make an overhang feature on any part. This material is non-toxic and you can just remove it with the help of hand or just wash it away. The next printer which we have is called Dimension, which is also from Stratasys. It uses the technology called material extrusion. It works on the same principle as a hot glue gun. It is extruding a polymer in thin layer and depositing layer by layer to make the actual part. It also uses support material which is breakaway, and you can just remove it from the platform to get the actual part. The next one which we have is Z-Core Spectrum Z510, which uses a binder jetting technology. So similar to inkjet printer, instead of spraying ink, it's spraying a binder material which is deposited on powder, and the powder sticks together to make the part. In this printer there is no support material because the powder actually works as a support material while manufacturing the part. When the part is finished, you just take out the part and spray with pressurized air to clean up the part, and your part is ready. With this printer you can also print colored printers with which you can also print pictures or any actual model prototypes. The next one which we have is called MakerBot, which is now owned by Stratasys. With this printer also works on the same principle as the Dimension, where you're extruding the material and depositing layer by layer. We also have different kinds of scanners, from high range like Spectra Borum to a smaller one which is 3D Sense. And these scanners are very helpful in reverse engineering, where you have the part and you can just scan it to make it in our lab, or else it also used for a project for people who have amputated legs or amputated limbs, where you scan the partial limb of the person and then you have the actual model of that limb on the computer. So for a normal doctor it takes a longer time to make a mold and then cast it and then make the prosthetic. Then the doctor goes and checks it on the person. If it's not a proper fit, then he have to go and do this process again and again. It takes a very long time. But with the 3D scanner, you can scan the limb, you can have the part ready in the morning. If it's not a proper fit, you can make those small changes and then have the new part ready next day. With the scanners, we can also scan the residual limb of a person. Also, we can scan a head of a person to make a proper fitted helmet or to make a bust. We have also worked on a small project to make centrifuges, because a normal centrifuge costs more than $1,000. We came up with an idea and we talked to different departments at FSU, where we wanted to make a centrifuge which is a lot cheaper and which will save a lot of money. So we came up with a new design with which we printed out a centrifuge which costed less than $150. The major cost in this centrifuge is for the motors, the circuit boards and switches, and the material cost is very low. We have given this centrifuge to different departments at FSU and it's been working properly fine. We have also made a small attachment to it to make it as a magnetic stirrer. So this centrifuge works as a centrifuge as well as a magnetic stirrer.